Hello there! This video will show you how to compute the standard deviation and coefficient of variation using formulas and pivot tables for both raw data and data that's already in a frequency distribution table. So, in the lecture, you saw these formulas computed manually, but as you'll see in Excel, it is much simpler to use Excel for this than to get out your calculator and do it by hand. That's a little rough. So the first thing we're going to do is look at the mean number of loaves sold for each type of bread. So you'll see the different breads are represented up here, and then how many loaves were sold for each day of data collection is here. Now I am going to go ahead and go to View, Freeze Panes, and freeze the top row so that when we scroll down we'll still see the kind of bread that we're working with. So first we're going to figure out the mean, then we're going to do the sample standard deviation. I'm going to use the sample standard deviation since this isn't all the bread ever sold at Great Harvest Bread Company. Then we're going to use those two values to compute the coefficient of variation. So just to kind of set up this worksheet, I'm going to type in mean equals SD for standard deviation equals and CV for coefficient of variation equals. So equals, and you've done this before, average, double click, click the last value, hold down shift, click the top value, or just simply click and drag to highlight, hit enter, there's your mean. Now again, you don't have to do this for all of these. Excel is smart. You can copy that formula over by either going to the bottom right of this where you see that black plus sign, click and drag over, or you can highlight, drag over, select home, fill, right. All right, now let's do the standard deviation. Equals STD. Sorry, I'm kind of childish like that. All right, you want to double click stdev.s. That .s means for the sample. Highlight your scores. Start with the bottom, hold shift, click to the top, or click and drag to highlight all of them. Hit enter, and there's your standard deviation. Much like with the mean, the standard deviation formula can be copied across for each type of bread. And just to show you how this works, if we click on this cell, you can see that we're doing the standard deviation for the sample, and we're looking at C2 through C22, which makes sense because this is our C column right here. Okay, now our coefficient of variation is equal to the standard deviation divided by slash the mean. Hit enter. Now, we don't have to do that over and over again. We can just go to the bottom right, plus sign, copy that formula over, or use the fill function. We get our coefficients of variation. Now, these numbers look ugly to me. I'm not in love with them. So for the mean and the standard deviation, let's go ahead and round those to whole numbers because we're looking at whole loaves of bread. Right click, format cells, number, 0 decimal places, and then click OK. Now the coefficient of variation formula is technically the standard deviation divided by the mean times 100. But in Excel, you can just take these decimals, highlight those values, right click, go to Format Cells, and select Percentage, and that's going to convert it into a percentage. And let's just stick to 2 decimal places. So now we can see here, and I'm going to zoom in a little bit. Here is the percent, what percentage is the standard deviation of the mean. So if we look at these standard deviations, it looks like sourdough has the most consistent sales because the standard deviation is the lowest, it's 29. Followed by pumpkin chocolate chip having the next most consistent sales because it has the next smallest standard deviation of 34, right? They both have the lowest standard deviations. So based on standard deviation, we would think sourdough and pumpkin chocolate chip have the most consistent sales. However, these standard deviations are lower because we're working with smaller numbers. Overall, we're selling fewer loaves of those two types of bread compared to the other types of bread. In fact, once you examine the coefficient of variation, pumpkin chocolate chip has the least consistent sales, right? It has the largest coefficient of variation. And sourdough has the second least consistent sales, or the second most inconsistent sales, because the coefficient of variation is the second largest. So you see how the interpretation of which one has the most consistent sales is best reflected in that coefficient of variation, because we're controlling for the fact that we're just working with smaller numbers to begin with for these two types of bread. Now keep in mind, if your goal is to compare how consistent sales are, the coefficient of variation is always the best. However, if you want to know the margin of error in loaves, or for how many types of bread to stock on any particular day, you'd want to use the standard deviation. Because again, comparisons don't matter if you just want to know how many loaves of bread to stock each day. That being said, if you really wanted to know how many loaves to stock each day, while considering that margin of error, the standard deviation, you would want to look at the mean and standard deviation for the number of loaves sold within each specific day, right? Because this is going to tell us overall across any given day. But really, we're trying to figure out how much to stock each day. So we need to jump into pivot tables to figure out the mean and standard deviation for each type of bread for each day, and then we can use those values to figure out the typical range in number of loaves sold within each day, using the mean minus the standard deviation to the mean plus the standard deviation. So let's go ahead, go up to the top, highlight the day of the week all the way over to the different types of bread, all the way down to the last row in your data set. Do not highlight these descriptive statistics here. Click Insert, Pivot Table. Make sure that this is what that looks like. New worksheet needs to be selected. Click OK. Now real quick, I'm going to just label this. You can double click it to highlight it, or you can go to right click and hit rename. So I'll show you what that looks like too. And we're going to say MSD bread by day. Hit enter. All right, click on this little spot that says the field. If you do not have this field pop up, make sure the field list button is selected. Sometimes it won't be automatic. So we're going to click day of the week, and that's going to automatically pop it down into rows. If it did not, if you click day of the week and it went somewhere else, right click on that, or click on the arrow, remove the field, and click and drag it into the right place. Now we are going to take harvest white, click it, it goes to values. Now typically you could just go through and click all these if you just wanted one value for each, but I want the mean and the standard deviation. So I'm going to say harvest white goes here, and then I'm going to take harvest white, put it in again. Honey whole wheat, and then honey whole wheat again. Just kind of click till it gets to the bottom. See that little kind of green line popping up there at the bottom? And just drag it there. Then I'm going to do light wheat twice. Pumpkin spice twice. Oh, that rhymes. How nice. Pumpkin chocolate chip twice. Now I'm hungry. That sounds good. Oh, something weird happened, right? I don't think it went down there. So let's do it again because it's not checked. Pumpkin chocolate chip. And then do it again. And then sourdough. And sourdough. And then Cinnaburst. And Cinnaburst. Now I'm just going to quickly look at my table to make sure that I have harvest white twice, honey whole wheat twice, light wheat twice, pumpkin spice twice, pumpkin chocolate chip twice, sourdough twice, and Cinnaburst twice. Hooray. So you can either do this right here, click the arrow, go to value field settings and select average. And then for the next one, for the same type of bread, value field settings, standard deviation. You'll see for here, if we do it for the population, it's right there. So we just do standard deviation. Or I find it easier to just go here, right click, value field settings, average. For the first one, for the next honey whole wheat, right click, value field settings, standard deviation. And I'm just going to do that for all these different types of bread. So for the first light wheat, we want it to be the average. For the second light wheat, I want it to be the standard deviation. For the first pumpkin spice, we wanted to do the average. For the second pumpkin spice, we want to do the standard deviation, and then just finishing that up for the last few. So we want the average. Here we want the standard deviation. Here, right click, value field settings, average. Here we want the standard deviation again. And then finally, we're at center burst. It's all coming together. For some reason, this did count instead of sum, which is strange. Maybe because there's some missing values in there. Average, and then standard deviation. Now, it's perfectly fine to work with decimals if you want to, but it's kind of bothering me. So I'm going to highlight all these values, right-click, format cells, number, and we're going to go down to 0 decimal places because we're looking at whole numbers, whole loaves of bread. All right, so now we have the mean number of loaves sold for each type of bread within each day and the sample standard deviation of loaves sold for each type of bread within each day. So now I want you to figure out, based on the mean and standard deviation, the typical range for number of harvest white loaves sold per day. So we're first going to start by just copying, so highlighting the days, Control C, click on a cell below, go up to paste, the little arrow below it, and we're going to paste the values. So we're not trying to create a new pivot table, we just want those values from it. So you click that. Then I'm going to put low end harvest white, and then high end harvest white. So remember, the mean kind of tells you the overall trend. Then the standard deviation tells you, on average, what is the difference in number of loaves sold from the mean on any given Sunday. I'm going to go ahead, and before I do anything, I'm going to center these up here in the Home tab just because it looks better. So what we're going to do for the low end, we're going to take the mean minus the standard deviation. For the high end, we're going to take the mean plus the standard deviation. And we're going to use formulas to do that and then copy those formulas down. So we're going to put equals. We're going to click on the mean for harvest white on Sunday minus, click on the standard deviation for harvest white on Sunday and hit enter. Then we're going to click and drag that formula down. So click and drag down. Whoa, what happened? That was weird. So let's see. Click and drag. Fill down. That's still weird. Let's try this. Okay. So equals this minus this. Okay, let's see if that makes it smarter or if it screws it up. Look, it totally screwed it up. So something's funky with the pivot tables. So let's undo that. And I know how to fix this. Sometimes when you're working with pivot tables, it messes with the formula function. So let's just highlight this, Control X to cut it, and then let's go down to like cell 24 and Control V to paste because we're going to do this again. Now go ahead and click in here, hit Control A to highlight the entire thing, or you can click and drag. Hit Control C to copy, or go up here to copy. Then click right below, and let's paste special the values. So do that. Now it's not pivot table-y anymore, and it's going to let us use our formulas. Now this is still bothering me that it's not whole numbers, so I'm going to highlight all this data. Right click, format cells, number, down to 0. All right, feeling good now. So we're going to do same thing I showed you before, but now our data is not pivot table-y, so it'll work. Equals mean minus standard deviation equals. All right, 370. Now it should work. Click, drag down. Hooray! There's our low end. And that makes sense, right? 730 minus 49 is 681. 602 minus 61 is 541. So it worked. Let's do the high end. Equals the mean for harvest white on Sunday plus this standard deviation. take this formula, bottom right plus sign, copy it down. So just to confirm we did this right, if we look at Saturday, 813 minus 64 is 750, right? If we do equals 813 minus 64, and we get roughly 750. And then if we do 813 equals 813 plus 64, we get that 877. The reason this was slightly different is because although we have whole numbers shown here, when you do the math, it takes the entire value into account and then it rounds it accordingly. So now we know that on any given Sunday, we need to stock between 370 and 492 loaves of harvest white. And that is more revealing than just saying you need to stock 431 loaves. Although that's nice because it's kind of in the middle of those, this gives you a more idea about the range of values and kind of takes into account the margin of error for how much you need to stock. All right, now let's move into a situation where we have a frequency distribution table instead of raw data. So we're looking at the different catering packages, how much they cost, and let's turn this into monetary values by highlighting, right-click, Format Cells, Currency. Bam, that looks better. How many of those packages were sold this quarter? Then you'll see the leftovers of how we got the sum of X and the sample size to compute the mean. So here we took this times this to get this all the way down, added these together to get this, and that's how we ended up with the mean. Well, now I want you to figure out the sample standard deviation for the catering packages. So to do that, we are first going to have to figure out the difference between each score and the mean. So we're just going to put X minus the mean. Then we're going to have to square that. So X minus the mean. And then I'm just going to hold Shift 6 to make a little caret, to put a little 2 there for squared. I'm going to double click this double-sided arrow and make the cell a little bigger. Then finally, because we have to take the frequencies into account, we're going to have F times X minus mean. Hold Shift 6, squared. Now this is not fun to do in a calculator, but with Excel, you do it once and then you're good to go. Just copy that formula and move on with your life. So for this one, we're going to have equals our first X value, package cost, minus, click the mean, hit F4. If you don't have F4, put a $ in front of the letter and a $ in front of the number that was selected. We F4 it because as we copy that formula down, we want to lock in that mean for every single one. We're using this same value for all of them, so those $ lock it in. Hit enter. If we do this, little plus sign, black plus sign at the bottom, click and drag down. Or if you do this, fill down, same difference. Now the next step, we need to square those values. So equals this star for times this. Now I believe you could also do equals this shift caret, right? Squared, and you get the same value. So click plus sign to drag it down, or again, just highlight, fill down. But we're not done yet, right? These do not take into account that there's 26 of these packages, the cost minus the mean squared. So here we go. Equals F, right here, star for times the squared difference between the price and the mean. Enter. Hold that. Drag it down. And there we go. Look at that beauty. Those are big numbers. Now we're going to sum that together, and that's our sum of squares. So equals SUM for sum. Double click. Click all these numbers. Hit enter. And our sum of squares is $141,000, $141,140.90. Let's just pop that in here. Sum of squares equals, Control C to copy or hit copy. Click here, Control V to paste. Whoa, look at that funky business. Watch this. I'm going to copy it again. And then so it doesn't do weird formatting, I'm going to go up here, paste, values, and it keeps it exactly the same. I don't know what happened there. It was weird. All right, now we need to figure out our sample standard deviation. So this equals squirt, because we're going to square root. If you remember the formula, it's the square root of the sum of squares divided by n minus 1. So equals SQ, double click squirt, click on your sum of squares, divided by left parenthesis n, right, or 243, minus 1, right parenthesis, hit enter. Oh, we have to put 2 parentheses there, but it fixed it for us. So yes, we want to accept that correction. And our sum of squares is 2415. Our standard deviation is 2415. I'm going to go ahead and click on this, right click, format cells, turn it into currency. So let's see if this makes sense, right? So we can see that roughly, we've got differences in our frequencies, but most of these packages were selling somewhat similarly. And we look at 2415 and we look at kind of the differences among these values, and that makes sense. That 2415 doesn't seem outrageous for how spread out the typical cost of packages that sold were. So I'm feeling good about my math. Now let's look at the typical range for the price of catering packages sold. So if we go here, we're going to have the low end and the high end. So just like we did earlier when we're looking at the typical range of scores, to get the low end, we do equals the mean minus the standard deviation. Bam. To get the high end, we do equals the mean plus the standard deviation. Boom. Now this is bothering me. This mean needs to be format cells, currency. There we go. I feel better now. So although we can clearly see that in the raw data, most packages sold are between $39-ish and $88-ish dollars, it's important to note that in many situations, right, because we can see that here, in many situations you may not have access to the raw data. So being able to compute the range of most scores, the majority, just using the mean and standard deviation provided is extremely useful, because sometimes all you know are these two things, and you can really get rich detailed information just based on those two numbers, even if you don't have access to this right here. So this was a little intense. I hope that you enjoyed learning how to figure out the standard deviation and coefficient of variation with Excel. Although, especially when you're using frequency distribution tables, it is a little bit intense. There's a lot of steps. It is much easier than busting out a calculator and doing it by hand.